Hi, this is Karen O'Brien, and today I'm going to be doing part 2 of Module 10, which is to add the structures and in and out conditions to this channel. So I've already completed this, but I wanted to start by showing you how to recover a project. So if I had made a really bad mistake in this project and I couldn't redo it or I couldn't undo it, I couldn't fix that mistake, this is how you would kind of recover from something like that. So first of all, we'll just close out of, well, keep your eye on this right here. Keep your eye on these three files right here. I'm going to close out of QGIS. And then as you can see, those two files disappeared because they were just like placeholder files for the geo package. And then if I were trying to do make a recovery point, I would just zip these two. But instead, this time we're going to delete these two files because we're going to suggest that something was wrong with those two files and that they were broken. Now I am ready to start my lesson from step 9. So I'm going to extract this from here well, I'm going to use 7Z, but normally you would just right click and then extract, and you want it to be in this same level. So using 7Z, I'll just click extract here. If I was using like the regular Windows extraction tool, just make sure the two files go right here so the path isn't broken and they not fixed. So what I was just opening was this guy right here, lesson 2 complete, because I finished it in order to test for this video. And then lesson 2, step 9, okay, is where I want to start from. So I extracted that lesson 9, okay, and now I can open it and it'll get me right back to that spot. The key to this procedure is to close QGIS before you build a recovery point or extract a recovery point. We'll click load the model, and I'm going to turn these back on because this is part of the lesson. And then this is ready for step 10. Now that gets me over here to the updated lessons. So what we have here, I wanted to show you this. This is Flow2D setup, and this is new. So I kind of just rearranged remember the tutorials are all in this documentation.flow-2d.com. And then I updated this with a new video on how to run the installer, something a little more easy to follow. The link to the installers is right here. And then what you need to set your stuff up is just these 4 installers. And then if you mess something up, there's some extra material in here in the self-help kit. And this all goes along with lesson 1 through 6. So that's all updated. Run your installers. There's some simplified installation instructions down below. And what we were working on is module 10. And in module 10, we were up to, this will update in a second, but for whatever reason, it takes a while for it to load. And we were up to step 2, 3, 4, 5. Here it is, 10, step 10. And step 10 has an inlet and an outlet and a placeholder video for when this video is complete. So the object of today's lesson will be to zoom in on the upstream part of the channel so that we can add an inflow node. Then we'll turn off these layers that we don't need because we don't want to add our inflow node to a user layer. We want to make sure and add it to the schema data. Then we will click add a BC point on the boundary control widget, and then click save on the widget. And then we need to update our data for the new time series. And this GIF shows you how to do that. And this method also shows you how to do it. And then move on to the outlet. So let's start first with the, let's see, we're going to start first with the inlet node. Okay, so we zoom in right here. And like I said, we want to get rid of this stuff because we don't need it. So I'm going to turn off the user channel data so that we don't actually accidentally assign our boundaries or culverts to the user data. And now I want to open the boundary condition editor, and I want to click this guy right here, And then I want to just click on the very first cell. It can be anywhere, just make sure it's inside this cell and it's on the left bank. Click OK. That was an inflow node. Back over here, we'll click Save. Just click OK on that. It's just a message. Now, when I did that, it automatically assigned the other time series, which I don't want. The Grover in time series is not the one I want. So what I'll do is I will create a new time series. And now let's just finish this out by naming it Greenway in. And we need to name the time series. Okay, the time series will be Greenway in. Excuse me. I had to sneeze, so I had to go. I had to mute myself. 24-hour, 100-year. I've had a cold, and it's a doozy. Click OK. That names the time series, but we still need the time series data. The time series data is back in lesson 2, and you can see it's right here. So we'll just open that up. Control A will select all. Control C will copy that, and Control W will close that file because we don't need it once we've copied the data. Put your cursor right here and click this first cell, and then click the paste button, and you can see that we have our new hydrograph. And this is a channel hydrograph, so be careful that make sure that you assign it to channel. And then this one is almost done. The final step is actually to schematize it, but let's put the boundary condition on the downstream side first. Now the downstream boundary goes right here again on the very last left bank node. We'll click this guy here and click it again. And this time we need to change this to outflow because it's a downstream boundary condition, and click OK. Now, again with the save button, and now we need to switch to the outflow side of the table, and we'll name this Greenway out, and we'll set this to 3, floodplain and channel outflow. Now I don't need to do anything else. I'll just click schematize. So my inflow boundary condition will be applied to the first cross section of my channels, and that means the water will enter the cross section first and start flowing down the channel. The water will not share with the floodplain until it can fill up the channel. In this case, that just won't happen because this channel is massive. The downstream boundary condition is also assigned to the whole cross section. So as the water comes down the channel, it will hit this last cross section and it will leave the channel as a sink at a normal depth boundary control. Now you can add other boundary controls, but for this case, it's just a normal depth. There's nothing down here preventing the water from just moving out of the system. Okay, that is done. So we can now use the schematize button to burn those into the schema layers. And if you see here, my color of this cell has now turned to green as an inlet, and the color of this cell has now turned to blue to represent the schema outlet. And that is done. So we can close that editor. And if we go back to 10, you'll see we finished outlet. We followed all of these steps. We did the schema and everything was ready to go. Next is to put in the culverts. We have an upstream culvert at 20th Street and a downstream culvert at 16th Street. And we're going to digitize both of these into the system. Now note, important, when you put in a culvert, you only need to connect the left bank to the left bank. So that's really all you need. So first we'll zoom to the culvert, and then we will open the culvert editor and add the structure. And then we'll digitize both of the culverts. We'll start with 20th Street, which is the upstream culvert, and then we'll pan to the downstream, add that one, and then we'll click the save button because the culverts don't have any special attributes that you have to add in this step. All the attributes are added below in the widget or in the table editor. Once we name the structures and set them up, we will import the rating tables for each structure, and then we'll hit the schema button. And this is kind of what your last setup will look like. Then we'll come back for the export step. Okay, I'm going to minimize and I will just zoom in on this first structure. And again, I don't really need the elevation right now, so I can just turn that off. So you can see that this is 20th Street, and go to the structure editor, click this guy right here. Now this is important. Click the left bank upstream and then click the left bank downstream and then right click. Now that digitized polyline is complete. So we'll just go down to the next structure on 16th Street, and same thing, click the left bank and then click the right bank and then right click. Now note, it's not important to click right on the center of the node, just have to be in the cell. And I'll show you why what that does in a second. Okay, back here, we can click the save button and you see that we have both our structures are right here. Now, if I click the center button and I move between the structures, it will pan the map to the structure that you're looking at. Now, let's first off just set up the attributes of these structures. We'll name this one Greenway 1, and it's very important that this name matches because over here in our lesson, we have our rating tables and they have to have the exact same name as the structure so that when we import those, they'll come in correctly. I'm going to set this to channel. That's very important. This is because this goes from channel to channel. This is a rating table, and I'll leave the rest of these alone until we get to the data is done. I'm going to move to the next structure. This is structure 2. We'll just call this one Greenway 2. No, I did that wrong. Let's try that again. And now we see we have Greenway 1 and Greenway 2. We need to change this one to channel. If you don't set that from as channel to channel, it will not flow. All your water will just pool up here until it can spill out of the channel, and then maybe it would flow as a floodplain structure. So that needs to be channel. Now this one is not so important, so I'm going to leave this one here so you can see what happens if you don't change it. I'll click import the rating tables. It brought me right where I just showed you because I was already there. Just select both of them, or if you have a whole bunch of them, just Control A to select them all and click open. And then it asks you right away, do you want to change that rating table type to iCurve table? Say yes. And now you can see that that changed straight to rating table. Now, this did not update because we haven't loaded a structure. So you have to load that structure to get that to update. Now this is good, ready to go. And so what happens with a structure? Let me just explain these. So if you have a rating tables, what happens is that the water will run down the structure. And once it gets up to 0.1 feet of depth, it will allow 2 cubic feet per second to pass through the structure. And as the water from upstream increases in discharge, it will fill this to a deeper depth, which will push more water through the structure. But the control is this table. Now, in this case, I am using no tailwater effect. The discharge is based on the headwater, and that's kind of because I have a bit of a drop right here where the water just kind of falls away from this structure. So I'm not too concerned about a backwater condition right here. Now, if you have a backwater condition, Flow2D is going to tell you, hey, the head on this side of the structure is getting higher or approaching the head of this side of the structure. You need to turn on your tailwater switch, and you have 2 switch positions, reduced discharge and no upstream flow allowed. This is a flap gate. So it would reduce the discharge based on the head and the submergence criteria. So as the head down here gets close to the head up here, the discharge is through the structure will be turned off or dampened or turned off. And then if you chose this one, reduce the discharge and allow upstream flow, If the head on this side of the structure becomes higher than the head on this side of the structure, it will allow water to reverse flow through the structure and move upstream until, that condition no longer exists, and then the flow will reverse and go back into the right direction. So that's how the tailwater works. If you have a reference elevation for the headwater, what that means is that so the default is 0. That means that as the water flows down the structure, it will start to utilize this control at the invert of this particular cross section. Now, if you put anything in here that's above 0, then it will use that. It won't start to flow until it reaches that elevation. So in this case, our cross-section elevation right here is like 1400 something. So it would have to be something slightly above that. It could be a weir, it could be something slightly upstream of a drop structure, a V-notch or whatever, and then it won't start to pour over that weir until it reaches the crest elevation of that weir. That's how you use a reference elevation for headwater. You can do the same thing on pumps. It has to get up to a certain elevation before it can turn on, and then the pump turns on. Or you can do it for like a raised, sometimes you might see like a riser, and so that reference elevation is like the base of the riser where the holes open and allow the flow to enter into the riser. For rating tables, you don't typically need the culvert length and width, and I don't actually even recommend that you use it. But if you have a culvert that's really long, say like 1,000 feet, you can put in the culvert length and the culvert width, and then an area, and then the water, the volume and timing in the table will be applied as the water enters the structure and leaves the structure. It'll account for that extra volume and that travel time through the structure. However, if I have a culvert that's more than 1,000 feet long, I'm pretty sure that that's a storm drain conduit, because it's probably also going to have other inlets sharing flow with it. So I don't use this. If I have something that meets that criteria, I just switch it to a storm drain feature and put it in as a storm drain conduit with whatever inlets and outlets that it might have. Now let's see, I think we need to hit the schematize button to finish this off. And I just wanted to show you this because, as you can see, when I put in my my digitized user data, I just put it inside the cell, but the schema data puts it right to the center of the cell. That's just the difference there. And now these culverts are ready to go. Note that when you hit that, it didn't really tell you that it was done or anything, so you just have to kind of trust that it finished it. And let's go back down here to, let me check something right here. Okay. All right, I'm going back here to this guy, and I'm going to refresh this page because I made some changes to that were in the works. Export. Okay, now this is good. Yep, this is all good now. Okay. All right, so the next step will be to export the project. So we have to set up the control parameters. That'll be this guy. I don't think we're using rainfall in this one, so this image might be a little bit different for our video. But if you're following the step-by-step instructions, you'll have rainfall. Click the export button right here. And again, I'm not using rainfall, so I don't actually have rainfall. So these two don't really match. And QGIS lesson 1, we'll choose the export folder. This lets us know what was exported, and then we'll run the simulation and then save. Okay, and then can create a backup point. All right, so we will go here and make sure that this one is main channel and hydraulic structures. And then we hit save. And again, like I said, I didn't put rainfall and infiltration because I want to test the channel with just the inflow. So I click save. And let's see what else we got here. I'll go ahead and export it. And again, I don't have rainfall, so I'll just uncheck that. Click OK. And new folder. Nope, sorry. Wrong location. Lesson 2. Now I'm going to do a new folder because I already have this completed. So I'll just place just video export. and paste. Oh no, just select it. Just select the folder, and then it tells you what you've exported. Now I've already exported this and run it, so I just wanted to let you see that. Lesson 2 export, and everything has already been run. So I will go ahead and skip that step in the test because it's already finished and ready to go. So that, let's see, that concludes this portion. The next video will show you how to look at the data and review the data to see if it's running correctly. So I'll stop the recording here.